Okay, today I'm going to show you how to find the inverse of a function. So title this page Function Inverses. Alright, let's start with something really simple as an example. We'll say linear function f of x equals 2x plus 3. We'll use that as our example. Okay, there are 4 steps for finding the algebraic inverse of a function. So the very first step is to replace the f of x with y. So for our function, we'll now have y equals 2x plus 3. Okay, step number 2, then we exchange or switch x and y. They just trade places. So I'll have x equals 2y plus 3. Now the third step, this is the one that may be a little time consuming, but we need to solve for y. So solving this equation for y, we subtract the 3 from both sides and then divide both sides by 2. So that'll give us our new y. Now the fourth step is to, if the result is a function, not always will you get a function, then you replace y with the function notation, f inverse of x. Alright, so f inverse, this is read f inverse of x. Now, to check and see if these two functions are actually inverses of each other, we do the composition of the two functions. Okay, if the composition result is just equal to x, then the two functions we have are inverses of each other. So let me show you. I'll do f composed with f inverse. Okay, we're going to rewrite this in the other notation. So f of f inverse of x. And now I'll replace the f inverse of x with x minus 3 over 2. X minus 3 over 2. And this is what actually gets plugged into our function f for x. So from this point we'll have 2 times x minus 3 over 2 plus 3. Now, simplifying this, the 2's cancel out. And that leaves us with x minus 3 plus 3, and 3 minus 3 is 0, and so we're left with x. Okay, so f and f inverse really are inverses of each other. Now, this is one time when we do the composition where the inverses actually are equal to, or the compositions are actually equal to each other, or should be equal to each other. They will always be equal to x.